So these are similar to homework problems. I just changed the numbers. You have a tree nursery that sells a tree after 7 years. Okay. The growth rate is dH/dt. The function h prime of t equals 1.6t plus 3. Okay. T is in time. T is time in years. Okay, we'll have height is in centimeters. The trees are 14 centimeters tall when planted. Okay, first part is find the height after t years. Find h of t. So it's like what we did before. You take your h prime of t, integrate that to get the h of t, but you'll have to solve for c with an initial condition. So we'll write the initial condition down. "14 centimeters tall when they're planted, or when t equals 0. So h of 0 will equal 14. It's initial height. Okay, first. H of t is the integral of h prime of t dt. H prime of t was 1.6t plus 3. 1.6 times t squared over t. Plus 3t plus c. Use your initial condition to get c. Okay, see, 1.6 divided by 2 is 0.8. So 0.8 0 squared, 3 times 0, and then c. Then replace h of 0 with 14. this side, you've got 0 times the number is 0. Same with that one. 0 plus 0 is going to leave C. Okay, finish with an answer of h of t is 0.8 t squared add 3t add 14. So that was your height after t years. The height in feet. So feet. T minus time is years and h is height in centimeters. Okay, let's find part B. How tall are the trees when they are sold? Okay, so in the problem, you're told that they sell a tree after a certain number of years. I think it was 7 years. T equals 7. Okay, find h of 7. That'll give you your height at that year. Okay, 0.8 times 7 squared plus 3 times 7 plus 14. And I used a calculator. I like Desmos Scientific Calculator. It's a free online calculator. Gave me 74.2 centimeters. So a new example where the growth rate is given by growth rate. Let's see, I got there. Of a population can be modeled by we've got dp dt equal to 120.1 t plus 2,750. So derivative of p with respect to t models the population size. And you're told that t is time in years. Also, okay, t equals 0 corresponds to the year 1982. To give it some more information, the population was 230,000 in 2007. All right, first part is find the model for the population. We're going to call it PFT. Before we do this, we'll write some initial condition down and then go through the steps of integrating, solving for C, writing your answer. Oh, cool. Someone also mentioned Desmos. Yeah, Desmos has graphing calculators and a lot of cool things that I haven't even checked out yet. I guess as a side note, you don't want to rely on it too much, but another good website is Wolfram Alpha. It's more for finding solutions, but they also give you graphs and lots of fun calculations for your problem. Okay, integral of that function, which was 120.1. 2,750. T squared over 2. This times t and then plus c. Oh, I forgot my initial condition. Oops. Let's put that here. No, we need. So even though you have t equal to 0, you don't know anything about p of 0. What you do know is something about the population size for another year. So what you do is take, let's see, in 2007, you do have a population size. So you have to figure out what t value that year would be by subtracting the initial year, 1982. I got 25. Okay, for that value of t, the population size was 230,000. Okay, back to solving for C. 60.5 t squared plus 2,750 t. We're going to put in 25 through this general solution. And replace P of 25 with that value. 230,000. It's going to rewrite all of it. Okay, trying to get this C, which is sitting on the board way up here, by subtracting this number from 230,000, and I got C equal to 1, 2, 3, 7, 1, 8. Final answer is 60.5 t squared. Add 2750 t, add this number. Okay, next is predict. So this is a function for time in years. We'll give you the population size at that time. So find the population size for the year 2018. So you have to figure out what t value corresponds to 2018. Take that year. Oh, subtract. Or you should see 1982. Got 36. And that's the value of t that corresponds to 2018. Okay, and then to get the population size at that time, put this number 36 into your function. It's 36? Yeah, 36. So 36 is the time we're interested in. Put that in right there. Again, I used a calculator, and the answer is 300,543.55. Oh, cool, some good to me. All right, so that should do it for this section. Let me know if you need help on your homework. And there's also just a reminder that you've probably used WebAssign before, but if not, I'm thinking to post a tutorial that's extra credit or just no credit. Anyway, I'm trying to say that every question has an Ask Your Teacher button, and I get those messages, and I try to reply as soon as I can. So you can email me or you can ask through WebAssign. Let's start 6.2, which is u subs. Okay, so the general idea if f is continuous, and u is some function g of x, then the integral of f of g of x times g prime of x dx is equal to the integral of f of u du. Cool. So I put a note of when you might want to try doing a u sub. Sometimes they help with the composition of functions. Sometimes this helps with a product of functions. And this is something to try if you're out of ideas. So if you have no other ideas, give this a try, see if it works. So the first example, we'll start with some side work. Let's do this. Okay, so we have f of x equal to sine of x to the fourth. Okay, the derivative will be cosine x to the fourth times 4x cubed. So we went here and took the derivative. Now we'll integrate this and see that we go back to sine, to the function that we had, sine of x to the fourth. So try this. So scratch work, let u be some function of x. We're going to let u be x to the fourth. Derivative of u with respect to x will be 4x cubed and we're going to multiply both sides by dx, I guess. So du is equal to 4x cubed dx. Okay, so u is x to the fourth, which we'll sub right there. 4x cubed dx is right here, and it equals du. So all of that will be replaced with du. Integrate cosine. Got sine of u plus c. And then go back to values of x. So sine of u, where u is x to the fourth. Cool. So we went backwards and we got, where we started. I do have steps to how to solve these. Let's do the steps, then we'll come back to this example. Okay, you let u be a function of x. Oh, I'm not sure I did it. Well, we'll write the steps down and we'll do another one, and then next time we'll do a bunch more examples too. So sorry if I did that last one quickly. Try to slow. Let u be a function of x. Well, I don't know. Before we erase this, let me just try talking through it. We'll write the steps down and we'll do more examples. So you start with some problem like this. Integral of cosine x to the fourth, 4x cubed dx. You pick a good u. I picked x to the fourth. So I just chose u equals x to the fourth. Took the derivative, isolate du, replace du with all of this. Or all of this part here is du. And then we just replace x to the fourth with u, because that's what we just chose that. Okay, so we've converted from values of x to values of u, do that integral, which is much easier, and then go back to values of x. We'll list all that down. So 2, you solve for x and d of x, dx in terms of u and du. So to pick u, solve for x and dx. Okay, then you take those and you substitute them into whatever problem you've got. So it's convert the integral to u variable form. After that, you should hopefully be able to do the integral. And after integrating, convert or rewrite the function in terms of x. After rewrite. The antiderivative as a function of x. Put 5 is check your answer by differentiating. So if you have time, check your answer. Okay, I have a couple examples. I'm gonna set a timer so I don't lose track of our class time. And we'll do as many examples as we can. So probably would ask to simplify or compute or find. This is we skipped this. The integral of secant squared of 4x dx. Okay, you have to pick some u. I chose 4x. Okay, so you could put secant squared of u dx, but we need some kind of something with u du. So we'll do that over here. Du dx is 4 du equals 4 dx. What I will do is divide both sides by 4, and that gives me dx. And then I can get rid of this dx right here, or replace it with 1 over 4 du equals dx. Okay, the secant integral of secant squared u times 1/4 du. So I'll just replace this part. Dx is 1/4 du. Okay. So 1/4 integral of secant squared of u du. I've got 1/4 times, is it tangent of u plus c? And this function started with the variable x, and you want to finish with the variable x. So remember what u was. It's 4x. So sub that back in. 1/4 tangent 4x plus c. Yes, I hope this is starting to make sense. Examples will help. So next one. Integrate. It's the integral of the cubed root of 1 minus 5x dx. Okay, u will be 1 minus 5x. In some problems, you might have to try different u's and see which one works best. This one's a little straightforward. Let's do du dx. Yeah, -5. I didn't remember that negative sign. Du is -5 dx. Is that what I want? And I'm trying to get rid of or replace dx, so let's have -1/5 du equal to dx. So I can substitute anything from my scratch work. One part I want here is to sub u equals 1 minus 5x under the cubed root. And then dx is going to be replaced with negative 1/5 du. All right, negative 1/5. This is the integral of u to the 1/3 du. Negative 1/5 times. So let's see, 1 plus 1/3, or 3/3 plus 1/3 would be 4/3. And this is over 4/3 plus c. So 4/3 times negative 1/5. Make sure I did that right. So you'd have the 3 on the top and the 4 times 5 on the bottom. U to the 4/3 plus c. Okay, now let's put in u. U was 1 minus 5x. Oh, okay. I thought this was a messier answer. Okay, we've got negative 3 over 20. U was 1 subtract 5x. And there was a power of 4/3. And let's see. Yay! Oops. Let me see what you guys talk about. Did I make a mistake? Let me see. Yeah, looking back at the chat. We explained it. How did I get negative 5? Oh yeah, in the scratch work we did do a derivative. Yep. And then we go back, and that was just on the side to go over here and do the antiderivative. So we do have derivatives and antiderivatives. We just have to be clear of when to do what. So another example will be the integral of x times the root of x minus 1 dx. I picked u to be the root of x minus 1. And then I rewrote it as x minus 1/2 power. So it's easier to take the derivative. Du dx. 1/2 x minus 1. Let me make sure I do this right. Cool. 1/2 x minus 1, the negative 1/2. Okay, x minus 1 to the negative 1/2. We can put it in the denominator and change back to the root of x minus 1. Okay, so this problem needs a little extra work. What we've got so far is du dx equal to 1/2. And just remember, the root of x minus 1 was u. So we're going to put u back, or we're going to put u right here. So we had to play a little bit to get rid of the variable x, but now we can do dx on both sides and have du equal to dx over 2u. Or 1/2u dx is the same. I think that's all the sketchbook we need. Nope, I also have another note. Okay, I put that, u equals x minus 1 to the 1/2 power. And I squared both sides. And solved for x. That way I can sub all of the parts of this integral to be, so that way it's all in the variable u. So we'll sub x with u squared plus 1. We'll sub root of x minus 1 with u and replace dx with 2u du. Let's finish this part. So what we're doing is u again. We did some side work to get a value for x, u squared plus 1. We started with choosing the root of x minus 1 to be u. And with the scratch work, we got dx to be 2u du. Okay, so then we can just keep on working through this. Integral of 2u squared times u squared plus 1 du. So just take care of this part. 2u squared. This will give us 2u to the 4th, the integral of 2u to the 4th du. Plus the integral of 2u squared du. Okay, so I've got 2 times u to the 5th over 5. Add 2 times u cubed over 3. Last part is to put u in. U was the root of x minus 1. Okay, 2/3 times the root of x minus 1 cubed. And I just made this look a little bit nicer by changing that square root to a 1/2 power. So I put 2 times x minus 1, 5 halves over 5, and 2 times x minus 1, 3 halves over 3, add z. And that would be your answer. So I think U subs are tricky at first, but after you practice a little bit, it starts to make sense. We'll do more examples next time. Thank you, everyone.